We're going to be talking about what access lists do, packet filtering, standard access lists versus extended, some general guidelines to follow when creating and applying access lists, as well as the wildcard mask. Let's go in and talk a little bit further about what packet filtering will do for you. Packet filtering, that's what our access lists are going to do, are filter traffic based on certain criteria. We can filter traffic before the routing decision. So if we create an access list, depending on where we place it will determine whether it filters the traffic before the routing decision or after the routing decision. Let's take a look at what I mean. I have a machine over here on the other side of router B. And if I want to stop particular traffic from getting out of this subnet right here, what I could do is I could place an access list on this interface. And I would place the access list on that interface on the way in. It's very important to understand the concept of in or out when we're placing our access lists, because we apply them to an interface. This is a router I am drawing. We apply them to an interface, and then we have to specify the direction of the traffic flow, out or in. It's very important to look at the router as a room. Everybody's hanging out in the room. And these interfaces are doors. To get into the room, you've got to go in the door. If you're getting out of the room, you're going out of the door. So in this situation, a lot of times people look at their subnet as the inside. It's not inside of anything. It's inside the router is where the in or out refers to. So if I want to stop traffic from this machine, maybe this guy made me mad, so I'm blocking all his traffic from getting out. So I would put that access list on this interface on the way in to the router, because it's entering the router, into or out of the router. What I would do is just stop him right here before the routing decision. Maybe I want to allow this computer to go out of this interface, but not out of this interface. I don't want to allow him to go out of serial 0. So what I could do at that situation is put the access list on serial 0 on the way out. And what would happen is that would be after the routing decision. If the packet entered the router, it does all those things, does this routing table lookup, all that, it says, oh, that needs to go out of serial 0. Oh, wait, he can't. That's after the routing decision. So again, before or after, depending on in or out. Now we can permit or deny traffic. So it's very important to understand something with an access list. Let me clean up the slide and talk about that further. Much better. It is always important to understand that access lists are always going to be blocking some traffic, or at least that's the way they're designed, because at the end of every access list is an implicit deny any. So if I go in and I use a permit statement in an access list allowing this computer right here to go into this interface, and I just leave one permit statement, permit this IP, any other computers would be blocked. Because what happens is the access list makes sure that every IP address matches a statement. If it doesn't, it'll match this statement right here, implicit deny all. Unless it's explicitly told what to do, it's going to block the traffic just in case. Even though this guy might be trying to get out and the access list doesn't say to stop him from getting out, it also doesn't say to let this computer get through this interface. So to be safe, the router is going to block the traffic. So again, when permitting traffic, realize that you're blocking everything else. So permit statements are when you just want to allow a few types of traffic in, and then everything else would be blocked. Now, standard versus extended access lists. Cisco recommends that you place extended access lists as close to the source as possible. Extended access lists block very specific traffic. So I can block traffic from this guy right here only at port 80, so I could shut down his web traffic if I wanted to. So something like that, if possible, you put on this interface right here, maybe E0, as close to the source as possible. A standard access list, since it blocks all traffic from that particular host, they want as close to the destination as possible. So if I'm trying to stop, I don't know, this machine from getting to this subnet right here, maybe there's some servers and stuff like that. He's been messing around. I don't want him going over here for whatever reason. As close to the destination as possible would be on this interface, E0 on router C on the way out. So very important. Standard as close to the destination, extended as close to the source, recommended by Cisco. So again, with the access list, we can filter before or after the routing decision. Again, before would be on the way in, after on the way out of an interface. We can permit or block traffic. Just remember, at the end of every access list is an implicit deny any, and if it's not specified to allow the traffic, it's going to block it. And then with the standard, it's close to the source, or close to the destination, and extended is close to the source as possible. Let's go in and take a look at another slide. I want to go over standard access lists versus extended access lists a little bit further. Now, when we are creating an access list, there are certain number ranges that specify that type of access list. The numbers tell the router two things. One, they tell the router standard or extended. If the number is between 1 and 99 or 1300 and 1999, it's a standard access list. If it's between 100 and 199, 2000 and 2699, it's considered an extended access list. One additional thing it tells the router is the protocol. Any of these numbers here will tell the router that it's going to be looking at IP traffic. So right here between the data link and the network layer, actually the LLC portion of that data link sublayer specifies the type field. The access list will look in the type field, and the type field of a packet tells the device what type of layer 3 packaging was used, like IP. So in the type field, it's looking for IP traffic, and that's how it knows, because in the type field it says this is IP traffic. So it says look for IP traffic, and a standard access list is going to block or permit traffic based on a source IP address. So it'll look for IP traffic and then go in and take a look at the actual IP address that it originates from. That's all a standard access list is going to block on. So a standard access list would look something like this. Access list, and then we specify our access list number right here. If it's between 1 and 99, it's going to be standard, so I could use the number 1. And then I have to specify, am I permitting or denying? I'm permitting. I type permit. And then there's a couple different things I could do here. I could just put an IP address for the host. And basically whatever I put here is going to be the source address. We're going to get into that in more detail under configuring standard access lists. Now, very important, all traffic from that source, when it's a standard access list, is going to get blocked or permitted based on what you're trying to do. So very important to understand that you're not just blocking web traffic or telnet traffic or whatever, you're blocking all traffic from that source. An extended access list is a little bit different. My slides get so dirty so fast. Got to keep cleaning house. Extended access list, as I said, is a little bit different. 100 to 199, 2000 to 2699. So extended access list is going to look at a lot more than just IP and the source address. It does look at the type field as specified with the logical link control sublayer. So the type field right here is specifying IP traffic. It's also going to look at the IP information, source and destination address. So it's going to look inside the packet. It's called a packet at layer 3 of the OSI model. It'll look inside of that packet for the source and destination addresses. Then it's going to look at what's called the protocol field. The protocol number here, it'll look at that and determine TCP. We can block TCP traffic, UDP traffic, all different types of IP traffic we can block because it goes in and looks at this protocol field. And that tells the router whether TCP or UDP was used at layer 4. And the last thing it's going to look at is the port numbers right here in the OSI model between the transport and the session layers. It's going to look at the port numbers. The port numbers tell us the applications, like port number 80, HTTP. Most people know that port number. TFTP, port 69. So it's going to go in and look at the port number, and based on that port number, will tell the device what application we're blocking. So an extended access list is going to look at a lot more. Now, when we create these access lists, it's possible for us to block, let's say I'm going access list 1, permit, and then I want to block a particular address. So 172.16.01. Based on what's called a wildcard mask. Wildcard mask. I can block just this particular IP. I can block the entire 172.16 network. I could block the 172.16.10.0 subnet, or I could block a range of subnets, all depending on this wildcard mask. This wildcard mask is very important when creating access lists, as well as with OSPF and stuff like that. We use the wildcard mask. So let's go in and take a look at the wildcard mask and figure out how this thing actually functions. The wildcard mask tells the router whether or not an IP address is going to match the permit or the deny statement. So let's say I have an IP address of 172.16. I don't know, this machine down here will be in the 1 subnet, so it'll be 1.10. So if I want to block that particular machine or permit that particular machine, I would specify that machine's address, 172.16.1.10. And then I would put a wildcard mask of 0, 0, 0, 0. 0 means the entire IP address must match this statement. So when it's comparing information, so this, let's say this machine's IP address is .20. When this machine sends information, and let's say the access list is applied here on the way in, so it's before the routing decision, and the machine with an IP address of .20 sends information. The access list is going to check that packet and look at the source address, and it's going to go, okay, this has a source address of 172.16.1.20. Let me check against the statement. 0 must mean, is there a 172 in the first octet? There is. 0 must mean 16 in the second octet. There is. 0 must mean there's a 1 in the third octet. There is. 0 must mean there is a 10 in the fourth octet. There's a 20. So this IP address does not match this statement. You can have a bunch of different statements in an access list, and it's going to check them all until it finds one it matches. But the wildcard mask determines really whether or not it's going to match the statement. So this 0 here means it must be a 10, does not match the statement. If I wanted to stop all or permit all of the computers in this subnet, I would use this wildcard mask right here, 000.255. Let me clean this up, and then we'll take a look at what the 000 with the 255 in the last octet is going to do. Alright, I cleaned up the slide, and while I was at it, I just typed the rest of it out because my handwriting is not the best. So we've got the IPs 10 and 20 here, and what I want to do is I want to permit all of the computers in this subnet, and maybe I applied the access list here on serial 1 on the way out. So I'm allowing all these computers in this subnet on the way out. And what this does is it's saying, I'm going to take a look at this machine again, 172.16.1.20. So we've got the 172.16.1.20 sending information out of that interface, and the router is going to look at this statement and see whether or not this information or this source address applies. So he's going to check it. 0 means must be 172. Yes. 0 means must be 16. Yes. 0 means must be a 1 in the third octet. It is. 255 means it does not matter what is in the fourth octet. So since it doesn't matter what this is, it could be any number. It applies, and it'll permit that traffic to go out of that interface. If I want to allow the whole subnet, what I would do is I would use 172, or the whole network, 16.1.0, actually 0.0, 0.0.255.255, and that would permit the entire network. So maybe this might be, I don't know, instead of 172, it might be 192.168 up here. Might be this network up here, and we're allowing all 172.16 traffic to go out of that interface. So again, this is our statement, 172.16, the entire network. 0.0 means must be a 172, must be a 16. 255 means third octet doesn't matter what it is, fourth octet doesn't matter what it is. So any machine with a 172 and a 16 and the first two octets would be permitted to go out of this interface. If this, I don't know, instead of being 172.16 down here, if this was a 10.0.0.0 network, if this was the only statement permitting 172.16.0.0 out, these machines would not be able to go out of that interface, and only the ones with 172.16 in the first two octets would be able to go out of 192.168.10 interface. So remember, there's an implicit deny any at the end of every access list. Let me clean this up one more time and take a look at how we can block a range of IPs or a range of subnets. Alright, here is a situation where we're going to allow a range of subnets with one statement. So with this one statement, access list 10 permit 172.16.4.0 003.255, we will actually be permitting subnets 4 through subnet 7.0 with this one statement. So we don't have to mention the 7 in the statement, it's mentioned with this number right here. And what happens is basically, just like a subnet mask, the wildcard mask comes down to a bit comparison. The 0 means, okay, any IP with a 172 in the first octet. 0 means any IP with a 16 in the second octet, so it's got it. And what I have here is I have the .4 subnet, the .5 subnet, the .6 subnet, and the .7 subnet. And I broke it into binary so we could look at actually what's happening with this wildcard mask. So any machine with a 172.16.4.0, 5.0, 6.0, and a 7.0 is going to match this one statement of 172.16.4.0.003.255. I broke it in binary, so they're all going to have a 172 and a 16 in the first two octets. And then let's take a look at what happens next. 0, if we're looking at this 3 here, this is the 3 broken into binary. So 0 in this binary here must mean it must match. So they all have to match the first 6 bits in the wildcard mask have to match. And if you notice in binary, in the third octet here, the 4, 5, 6, and 7 all have the same first 6 bits. They have a 0, 0, 0, 0, 0, and a 1 in the first 6 binary spaces of that octet. Then they differ. 4 is 0, 0, 5, 0, 1, 6, 1, 0, 7, 1, 1. So since they all differ, we tell by using the wildcard mask of a turned on value there, it means it doesn't matter what is in that binary space. So it doesn't matter that there's a 0 or a 1 there. Any value matches. And by having another 1 there, any value matches there. So we cover an entire range of 4, 5, 6, and 7 by using this custom wildcard mask of 3.255. 255 again means doesn't matter what's in this last octet, so anything with a 172, 16, 4, 5, 6, or 7, and anything between any of those combinations of 1 and a 255 in the last octet is going to be valid and allowed to go through. So again, it comes down to where do they become different? And they become different right here between the 6th and 7th binary space in the octet. And so to cover that, we just turn those bits on and any combination is permitted. Now we can't just add any combination together. They've got to be sequential. It's going to start with an even number because we need to be able to cover any of these numbers in the back. So all we have to do is create a custom wildcard mask there. If we had the right subnets, and I wanted to do it an easy way, I wanted to figure out what would allow me to block 172.16.4.0 through 172.16.7.0. If I wanted to figure out what would allow that, all I would have to do is subtract the 4. I know it's got to be 172. It's got to be 16. And I would subtract the 4 from a 7, and that gives me 3. Anything goes in the last octet, and that'll tell me my wildcard mask. But you have to be careful. And again, this is what's happening in the binary. We're actually just turning a portion of that third octet on the bit values, so anything goes in the last 2 binary spaces, but the first 6 have to match a 00001 in the first 6. So that's our wildcard mask. And again, we can manipulate that in many different ways to permit or deny specific IPs, specific subnets, specific networks, or a range of IPs. So in this video, we've talked about packet filtering with access lists and the basic concepts. Standard versus extended. 1 to 99 means IP standard access list. 100 to 199 IP extended. And again, the big difference is standard only looks at the source address. Extended looks at the source, the destination, protocol, port number, a lot more information so we can get very specific as to what type of traffic we're blocking. Some general guidelines. Don't forget that implicit deny any at the end of every access list. Every access list has to have at least one permit statement. If it doesn't, it's going to block all traffic, period. And then the manipulation of that wildcard mask to get specific as to whether we're going to be blocking a host, a subnet, or a network.